This video I'm going to do number 36 from classwork 2.2. Okay, so this one says that you have two masses and they're hanging over a pulley, and each of them is initially 1.8 meters above the ground. Okay, and the massless frictionless pulley is 4.8 meters above the ground. What maximum height does the lighter object reach after the system is released? So first determine the acceleration of the lighter mass, and then it's the velocity at the moment the heavier one hits the ground. This is the launch speed. So I really like this problem because it's going to combine what we've learned about forces and tension with our questions from, or our work from the last unit, so our constant acceleration. Okay, so instead of having to redraw the whole figure, I'm just going to kind of leave it here as I go through. Okay, the first thing we want to do is we need to figure out, we know that it's going to tip this way, right? So we want to figure out the rate at which this object is accelerating, okay? So, and that would be the same as the rate at which this object is accelerating, okay? So the 3.2 kilogram is going to exert a force in this direction, so a force due to gravity in that direction, okay? And it then is going to pull on this guy over here, which has a weight that's pulling back on it, so essentially it's a force in the opposite direction. Is going to be a force tension that is due as a result of that weight, okay? So we sort of get that the force due to gravity, or the weight of the heavier object, so like this one heavy and this one light, the heavy object minus the weight of the light object is going to give us our mass times acceleration. Okay, so let's just plug in. We know that Fg is mg, so for the weight of the little one, it's going to be 3.2 times 10, so 32 newtons, minus the weight of the little one, which would be 22 newtons, is equal to mass. So here we have to take into consideration the mass of the entire system because the whole thing is accelerating. So it would be 5.4 A. Okay, so we just get 10 equals 5.4 A. And so the acceleration is 1.85 meters per second squared. Okay, so that's the first part. The first part is figuring out how fast these things are accelerating. Okay, now we want to find out what velocity is this guy going when it hits the ground here. Okay, so we have an initial velocity, okay, which is 0. Okay, I'm going to zoom in a little bit so we can see this. Right, I'll redraw our picture here really quick. Okay, so the initial velocity that this thing has is going to be 0. Okay, we have an acceleration that is equivalent to 1.85 meters per second squared, and we're trying to figure out what is its final velocity after it drops that 1.8 meters, so the displacement is 1.8 meters. You know, what is this final velocity is our question. If we find its final velocity, then we know this guy's final velocity once it is, raised up 1.8 meters. Okay? So let's just plug and chug. We want to solve for v final, so I'm going to use v final squared is equal to v initial squared plus 2ad. So we have 0 plus 2 times 1.85 times 1.8. Okay, 2 times 1.85 times 1.8, and then square root. So about 2.6 meters per second. So velocity final is about 2.6 meters per second. Okay, so what ends up happening with this thing is as we tip, so let me just redraw sort of where we are in this scenario right now. Okay, so here is the pulley again, and now the pulley looks like this. Okay, and the instant before this hits the ground, it's going 2.6 meters per second, which means because we have a system, this guy right here is going 2.6 meters per second as well, sort of in this upward direction. Okay, so what ends up happening is this guy then, when this hits the ground, the string is no longer pulling on him, it becomes slack, and he sort of jumps up in the air a little bit. Okay, so the question is, what is the maximum height that this guy reaches? So what we need to know now is, well, how high is he going to jump? We know he has an initial velocity of 2.6 meters per second. Okay, and once the system is no longer accelerating because of this weight, now it's just flying through the air. There's no other forces other than gravity working on it. So it's actually accelerating or decelerating at the rate of gravity. Okay, and we want to know, and another thing that we know is when it hits its highest peak, once it jumps up there, the final velocity is 0. Okay, and so we want to know D, like how high is it going to jump right here? Because we not only have this D, okay, which is the D of the jump, but we also have like the 1.8 meters, which was the original height, and the 1.8 meters more it went up in the air. And I'll redraw that a little bit in a second so we can see that more clearly. Okay, but given these variables, I'm just going to use the same equation as I did up here. VF squared, so VF squared is 0, is equal to V initial squared, so 2.6 squared, plus 2 times a negative 10, and now we solve for D. So I get 2.6 squared, and then if I subtract it on this side, divide by 20, I get D is 0.34 meters. So D is equal to 0.34 meters. Okay, so now let's put all the parts together and I'll redraw sort of a good picture here. Okay, so here we have them dangling sort of in their original position, which is 1.8 meters off the ground. Here, that's sort of not very well drawn to scale. Let me draw it a little bit bigger. Okay, so they are originally 1.8 meters off the ground. Okay, and then once this guy goes down 1.8 meters, now we are at sort of this scenario. Okay, so we have the original 1.8 plus another 1.8 plus we know that it makes this little hop up, which is 0.34, which we just calculated. Okay, so the answer to the question is 3.94 meters. This is the maximum height that this block reaches, is 3.94 meters.